Okay, let's discuss the dot product. The dot product is an operation that is performed between two vectors, and the reason we do a dot product is to get the angles between those two vectors. Okay? So if I had this vector A and this vector B, and I wanted to know the angles between them, I could use the dot product to find that out. So the dot product actually looks like this. A dot B is equal to AB cosine theta, where A and B are these vectors, and this A and B are the magnitude of these vectors. They are scalars. These are scalar. So the way we get the scalar is we say that A is equal to the magnitude of the vector A, which is equal to the square root of each component squared and the sum of all of those. So 3 squared plus 1 squared plus negative 5 squared. The reason I put plus and then negative 5 squared is because it is the sum of all of these products. Negative 5 squared will be a positive number. It will be positive 25. So the magnitude here, we could simplify this 9, 1, 25, and we'd end up with the square root of 35. Or we can simplify it further and say 5.91608. We find B the same way. It is the magnitude of the B vector. So we have the square root of negative 4 squared plus 5 squared plus negative 5 squared. That would simplify further. We'd have 16, 25, and 25, so we'd have square root of 66, which simplifies even further to 8.12404. Now we have our values for A and B. We need to find A dot B. What does the dot product actually mean? So for A dot B, what we will do is we will multiply our two I components and add that to the product of our J components and our K components. So 3 times negative 4 plus 1 times 5 plus negative 5 times negative 5. Okay, so this would be negative 12 plus 5 plus 25. Negative times a negative is a positive 25. So A dot B in this case is 18. Now the dot product is commutative. That means that if I were to say B dot A and reverse my order, I'd have negative 4 times 3 plus 5 times 1 plus negative 5 times negative 5. And I would still get 18. Okay, so how does this help me find the angles between them? If I say that A dot B is equal to AB cosine theta, then A dot B over AB is equal to cosine theta. And if I take the inverse cosine of both sides, I end up with theta is equal to the inverse cosine of A dot B over AB. Now I can simply plug in these values that I've already solved for here, here, and here, and I'll get theta. And this will yield an angle of 68.0058 degrees. Now between any two vectors, just two random vectors here, there are always two angles. There's this angle, call that theta 1, and this angle, we'll call that theta 2. Notice that these two angles make a complete circle. Your calculator will always give you the smaller angle of the two. So to find, we'll call that theta 1. To find theta 2, we need 360 minus theta 1. Which in this case we have 360 minus 68.0058. So our second angle is approximately 292 degrees. So now we know the two angles between our two vectors here, A and B. So that helps us, as well as remembering that the result of a dot product will always be a scalar. So the dot product, even though we're using two vectors, results in a scalar, always, always a scalar.